All right, let's take a look at question 6. This is also for section 3.5. So I think again we'll try to draw a diagram to kind of organize this here. So baseball diamond, 90 foot by 90 foot square. Suppose a baseball player is advancing from second to third base. So let's put him there. Runner. Umpire standing on home plate. Umpire. Let theta be the angle between the third baseline. So let's label the bases 1, 2, 3, and then home plate. But theta be the angle between the third best baseline and the line of sight from the umpire to the runner. So line of sight from the umpire to the runner. Third baseline is over here, bottom left. So theta will be here. All right, so I think this is a good diagram. Now let's talk about the variables at play here. So things that were, yeah. I think we should have a variable for theta. So that is the angle shown, and that's going to be in radians. How is that angle, like how do we define that angle? Well, the angle is from between the third baseline here. So let's say x is the distance from third to home plate. That's going to be in feet. All right. We have a triangle, so we have 2 other distances here, but let's make sure I actually need both of them, both the other ones. Baseball players advancing from second to third base at the rate of 24 feet per second. So that tells me that that's a rate I'm given. I'm going to label that distance. So y is the distance from runner to third base. That's also in feet. So I have another side of the triangle. Is there any reason I need to be looking at that? Let's see. Let theta be the angle that we've already talked about. How fast is theta changing when the runner is 30 feet from third base? I don't think there's any reason to kind of talk about the hypotenuse of this triangle. Let's see if we can get away with just using theta, x, and y. Before we go too much further, let's see if we can figure out what the goal is. What do we want to find out? So in the final question here, it says, how fast is theta changing? So a couple things to key on here. One, you're flat out told the variable, one of the variables you want to deal with, but you're also asking about how fast it's changing. So that signifies to me, I want a rate of change. So I want a rate of change of theta with respect to time. So this is my goal. I want to find d theta dt. So based on theta, x, and y, so those are my variables I think that I can, those are the only ones I think I need to worry about. What is a good equation that unites all of them? So I have an angle and 2 sides of a right triangle. I think I need a trig function, but let's think about which one we need. I have an angle, and what are the 2 sides related to that angle? X and Y are the legs of the triangle, so the opposite and adjacent side. So that tells me that I'm going to deal with tangent of theta. Tangent of theta equals what? Opposite y over adjacent x. So here's my equation. So what do I do with this equation? I don't have any time involvement yet, so I need to differentiate this equation with respect to time. So what is the derivative of tangent theta with respect to time? Well, first I have to differentiate tangent theta with respect to theta. So that becomes secant theta, or secant squared theta, times d theta dt. So I already see the variable that I actually want to solve for. equals what? So I need quotient rule here. So derivative of the top, so of the numerator, dy dt times x minus y times dx dt all over x squared. Okay, so now that we have our differentiated equation, let's try to figure out the rest of this information. So first thing I'm asked for is secant squared of theta. So in order to get that, I should know something about theta. So one thing we wrote down in here a bit ago is that tangent of theta is equal to y over x. We know what y and x are. X is a constant. X is 90 feet. What is y? So y changes. Y is a variable, but it should be, we should know what it is at some instant in time that we care about. It says, how fast does theta change when the runner is 30 feet from third base? So y is 30. So now I got tangent of theta is equal to a third. So I'm going to do something a little different. I'm going to try to find secant squared of theta without actually figuring out what the angle is. So, and this is basically to give you another way to think about these things. We have this Pythagorean identity for cosine squared and sine squared of an angle. But what happens if I divide this whole equation on both sides by cosine squared of theta? Cosine squared divided by cosine squared is 1. Sine squared of theta divided by cosine squared of theta is tangent squared of theta. What is 1 over cosine squared of theta? That is secant squared of theta. So, and actually, I'm not even going to solve for secant because what I really want is secant squared. So 1 plus tangent squared of theta. We said tangent of theta was equal to a third, which means tangent squared of theta will be equal to a ninth. So I think from there I can get that secant squared of theta is equal to 10 over 9. So we can fill in that blank. 10 over 9 times d theta dt is equal to all this stuff on the right. What is dy dt? So y is the distance from the runner to third. So how is that distance changing over time? So the runner is running at a speed of 24 feet per second. So I think I'm going to call my rate here negative 24 feet per second. Why negative? Because he is running towards third, so that distance is going to be shrinking. So negative 24 feet per second times x. X is a constant, 90 feet, minus y, which we already said was 30 feet, times dx dt. What is dx dt here? So x is the distance from third to home plate. It's the distance between two stationary objects. So that has to be a constant, which means the derivative has to be 0. All right, all over x squared. What is x? The x is the distance from third to home. So that's going to be 90 feet squared. So 10 ninths times d theta dt equals, actually, I'm going to make this a little simple for myself. That goes away because that's multiplying by 0. And then I have a power of 90 in the numerator, 90 squared in the denominator. So I think what I end up with is negative 24 over 90. And what are the units there? The units are kind of strange. They're going to be 1 per second. Basically, the reciprocal of seconds. So now, last step, multiply both sides by 9 over 10. So I get d theta dt equals negative 24 over 90 times 9 over 10. I'm going to reduce 9/90 to be 1/10. So in the end, what am I getting here? I'm getting negative 24/100 or negative 0.24 somethings per second. So what is the somethings here? It's actually radians, and it kind of seems weird that radians, we think of radians being this dimension, this unit that has a dimension, but really it's not. Radians are, I think the best way to explain it right now, but basically when you're talking about the angle, the measure of an angle, radians are kind of fundamental to angle measures themselves. We don't really think of them as having a unit. So then our final rate here is negative 0.24 radians per second.